we have to evaluate the given limit. At first, we're going to use that limit as x approaches to a of sum or difference of two functions equals to limit as x approaches a of first function plus or minus limit as x approaches a of second function. Therefore, limit as x tends to infinity of 3 times 2 to the power 1 minus x plus x squared times 2 to the power 1 minus x equals to limit as x tends to infinity of 3 times 2 to the power 1 minus x plus limit as x approaches infinity of x squared times 2 to the power 1 minus x. So that equals, we can take constants out of the limits, so that's going to be 3 times limit as x approaches infinity of 2 to the power 1 minus x plus 2 to the power 2 times limit as x tends to infinity of x squared times 2 to the power of negative x. So that equals to 3 times limit as x approaches infinity of 2 to the power 1 minus x plus 2 times limit as x tends to infinity of x squared, and 2 to the power of negative x we rewrite as 1 over 2 to the power of x. So now we're going to find first limit, and here we're going to apply exponent rule that says that a to the power of x equals to e to the power of natural log of a to the x, or e to the power of x times natural log of a. Therefore, 3 times limit as x approaches infinity of 2 to the power of 1 minus x equals to 3 times the limit as x tends to infinity of e to the power of 1 minus x times natural log of 2. So we can see if we substitute infinity, we get e to the power of negative infinity. So we're going to rewrite our limit as x approaches negative infinity of e to the power of x. So we have the same result times natural log of 2. Now we're going to apply the limit chain rule. Therefore, g of x equals to x times natural log of 2, and f of u equals to e to the power of u. So now we're going to find the limit as x tends to negative infinity of g of x. So it's going to be limit as x approaches negative infinity of x times natural log of 2. So that equals to negative infinity. So we substitute x with negative infinity, we get negative infinity times natural log of 2, or just negative infinity. Therefore, 3 limit of e to the power of x natural log of 2 equals to 3 times e to the power of negative infinity, or 3 times 0, and that's equals to 0. So now we're going to find second limit. So that's 2 times limit as x approaches infinity of x squared times 1 over 2 to the x. And here we're going to apply L'Hopital's rule. So we're going to differentiate numerator and denominator. So, okay, first we're going to rewrite our expression as fraction. So it's going to be limit of x squared over 2x. And now we can apply L'Hopital's rule as we have indeterminate form of infinity over infinity. So we differentiate numerator and we get 2x, and when we differentiate the denominator we get 2 to the power of x times natural log of 2. So if we now substitute x with infinity, we get also indeterminate form of infinity or infinity. So we're going to apply L'Hopital's rule again, and we get 2 times limit as x approaches infinity of 2 over 2 to the x times natural log of 2 squared. So now if we put x equals to infinity, we get 2 times 2 divided by infinity. So we know when we divide constant by infinity, we get 0. Therefore, that's going to 2 times 0 or just 0. Therefore, limit as x approaches infinity times 3 of 3 times 2 to the 1 to the power of 1 minus x plus x squared times 2 to the power 1 minus x equals to 3 times limit as x approaches negative infinity of e to the power of x natural log of 2 plus 2 limit as x approaches infinity of x squared over 2x. So that's going to be 0 plus 0 or just 0. Hence, this is the value of our limit.